Questions on Maxwell Boltzman diagram don't appear that often in exams. And in addition, there are only 2 or maybe 3 statements in the syllabus which talk about Maxwell Boltzman diagrams, and therefore teachers are reluctant to put too much time into this topic. Yet, if you understand these diagrams, it is very easy to deal with the question of 1 mark in paper 1 and a question which has 2 or 3 marks in paper 2. There are only a few things you have to remember. The vertical line is number of particles and the horizontal axis is energy. Now, sometimes that is written as probability. I will explain why. And in some cases in the internet, you will see speed of particle there, meters per second or something like that. But it's preferable to put energy. What we have here is 2 different curves at 2 different temperatures. The reaction is the same, the number of particles is the same in both cases. And the reason why it's referred to as probability is because the area under this curve there is equal to the area under that curve if you extend it to over here, for example. The area under that curve is equal to the area under that curve. And because of that concept, that the area under the curves is the same, T2 must be a temperature greater than T1. When you create a curve with a lower temperature, let's say T0, then it must peak up here and it goes down there. That's the only way you can get that area to be equal to that area and equal to that area. For the lower temperature, so that's the lower temperature, the peak must be higher than the others and it must be at a lower energy than the others. So that characteristic is very important, like that. Now that means if you have a reaction with an energy of activation EA, for example, and the EA is fixed for the reaction. Therefore, when you change the temperature, the EA remains the same. All that happens is that the number of particles with an energy greater than the energy of activation, which is in this area. In the case of T2, which has the higher temperature, there are more particles there than in the case of T1, which has a lower temperature, and more particles than in the case of T0, which has even fewer particles. Therefore, you can say at temperature T2, the reaction will go faster because there are more particles with that energy, and they will therefore collide more often. So therefore the reaction will be faster. In this curve, what we're looking at is 2 energies of activation. Now, as I've said before, the energy of activation relates to the reaction, not to the temperature. Therefore, the only reason there can be a different energy of activation is because there's something different about the reaction. And that something that is different is that this one has a catalyst. This one has a catalyst. This is the reaction without the catalyst, and there are this number of particles which have energy greater than the energy of activation. This one with the catalyst, there are, because the energy of activation is lower, created by the catalyst, therefore there are even more particles that have energy. So now we go to the 2 questions. Explain using one of the diagrams why the particles with temperature T2 react faster than those with temperature T1. Okay, we're using diagram A. And what we're going to say is that as the temperature increases, more particles have a higher energy. As temperature increases, more particles have higher energy. This is what the Maxwell Boltzman curve is saying, and therefore more particles have energy greater than the activation energy. Therefore, more particles have energy greater than EA, activation energy. And therefore you can say particles with a greater energy move faster and collide more frequently. Particles with greater energy move faster and collide more frequently. And that is why particles with temperature T2 react faster than those with temperature T1. In the question they haven't said temperature T2 is greater than T1, so you have to say temperature T2 is greater than temperature T1. Okay, actually that's worth 4 points. I think the question is worth 4 points rather than 3. But anyway, now B, explain why, using one of the diagrams, why a catalyst increased the rate of reaction. So we're going to use diagram B. Diagram B. And what we're going to say is catalysts reduce the energy of activation for the reaction. Catalysts reduce EA for the reaction. For the reaction. And secondly, we say with lower energy of activation, more particles have a higher energy and are available for reaction. With lower EA, there are more particles. With energy greater than energy of activation. And therefore there are more particles available for reaction. And that, I feel, is a good explanation of the Maxwell Boltzman diagrams. Take advantage of some of these questions that are relatively simple to remember once you understand them. If you found this YouTube video helpful, please subscribe to my channel, Solutions in Chemistry, and look at my other videos. Thank you.